Alright, this is a little video explaining all of the solutions to the Chapter 4 review. If you know how to do these problems, you should do absolutely great on the Chapter 4 test on Monday. So the first thing, we're just plotting points. I think you guys probably did well on that. You just always have to remember, you plot the x first and then the y. So x goes left and right and then the y. And then remember your quadrants. So this is quadrant 1. And then we have quadrant 2 here, and then we have quadrant 3, and then we have quadrant 4 that's here, and we use Roman numerals usually for quadrants. Okay, so scrolling down to the next problem, domain and range. Domain are always your x values. So as you look at the graph, the original dots that were there, I think the dots were, let me see here. So the dots were originally, these ones here. And so you would look at those dots and say, okay, what are the coordinates? So you have 0, 0, 2, 2, 2, 4. No, actually, 1, 2, 3, 4, 4, 4 is that one. And then this one, 0, 0, and 2, 2. Negative 2, 2, and negative 4, 4. And then you just identify what the x's are that are used there. So these are all the x's that are used. And the range are all the y's that are being used. And we only used a 0, 2, and a 4. So that's why this is the answer. Okay. Number 3, that's section 4.3 where we just had 4 ways to express a relation. The first way is a table that you could see here. And the next way is mapping. And that's this. When we say negative 2 goes to 6, and 3 goes to negative 2, etc. Make sure you put the arrows there, not just lines. And then graphing, we just plot the points. Negative 2 comma 6, 3, 0, 3, negative 2, and then 4, 6. It's that point right there. And then ordered pairs, that's the fourth way. So there's 4 ways to express a relation. And then 22 is, exactly the same thing. The next one, I'm not too crazy concerned about it, but you're trying to make your equation look like this, so that you have your x first, then your y, and then equal to some number. So you just have to kind of manipulate it a little bit. So notice on this one I added the y over, and then that gave me 2x plus y equals 6. And really that's the same thing as 2x plus y equals 6 with the 2x plus y on the left-hand side. So this looks really exactly like that. If you wanted to say, what are your a, b, and c, the a is equal to the number in front of the x, which is 2. The b is the number that's in front of the y, which is, there's really not a number in front of the y, so it's 1. And then the c is 6. When you look at this next one, whenever you have something squared, it's not going to be a line. It's going to be more of a different kind of shape. We'll learn these later, but it's going to look like this, or it's going to look like this. And so just know that whenever something's squared, either on the x or on the y, it's no good. So this is, no, it can't be written in standard form. All right. Use a table of values. Well, I'm hoping this one's the same as the one I gave you. I think. Oh man, I'm gonna have to look at it and see. It might be slightly different. One sec. Might have changed a couple little problems. Anyway, it should be pretty similar. This one is y equals 2x plus 8. So I think we're good on graphing lines. Just make a table of values according to your formative assessment. We went over that, so we should be good. Let's see. Determine whether each relation is a function or not. You just look to see, did you repeat the x's at all? So negative 5, 0, negative 2, 0. We never repeated the x's, so we're in good shape there. So that's a yes. And then if you look at this one, it looks like the x's repeat. So we have a 1 written there twice. So we say no good. It's not a function. And then for 39, it looks like we never really repeated the x's, so yes. And then as we scroll down to number 40, we just plug in a 2. Everywhere where there's an x, we just put in a 2 right there. So that's why we have 2, we have to square it, and then we got minus, and then we put a 2 in there, and then plus 1. So that's 4 minus 2, and then plus 1, and then 4 minus 2 is 2, 2 plus the 1, so we get an answer of 3. Coming over here to 41, if you plug in a negative 1 into the g function, you're going to have to square it. Well, same thing. So negative 1, you square it. Now, negative 1 times negative 1 is actually a positive 1, and then it's minus a negative 1, so that's really plus 1. And then we still had that plus 1 that was part of the equation, part of the function. So we add up all those numbers, and we get 3. Okay. Let's see, last page. This is our application problem. If you wanted to write an equation for this and you wanted it to count for any number of months, you know that you've got your initiation fee, that's $80, but then you're going to pay $50 times however many months you decide to join. So if you made a table of values, this would work. The first month, you just plug in a 1 for the x. So that would be 50 times 1, which is 50, plus 80, which gives you 130. And then if you want, you can keep plugging in these numbers in for the x and figure out what the c is. Or you can just keep adding 50, because you know that every month you're going to keep adding 50, because it's your monthly fee. You don't have to keep adding 80, because you already paid your initiation fee. All right. The graph on this just goes up, just like that. So you'll just do the same thing, just plot your dots. Is it an example of a function? Absolutely, because every time you have a particular x, you never are having to repeat. You don't repeat the x's. So every x is paired with exactly one y value. So definitely a function. Let's see. How much would it cost for 36 months? We would just have to take 36 and plug it into the function that we made. So we plug that in for x. 36 times 50 is 1,800 plus the 80, and that gives you 1,880 as a final answer for 36 months. All right, so hopefully that helps.